So logical domains are basically a virtualization facility that allows a system to be divided physically into a number of distinct machines, if you like, each of which can run usually a version of the Solaris operating system. The technology relies on a specific version of a Sun SPARC processor known as the Sun 4V architecture and referred to as core multi-threaded. You may have seen previous mentions of it as something called a cool threads server. And over the past 4 or 5 years, there have been a number of different processors available, in particular starting with T1, then the T2, T2 Plus, and then the current T3, which is being superseded very shortly by the T4, which should start shipping in December. These processors have a very large capacity in terms of the cores and associated threads. So a typical core that we're going to look at on the machine that I have here has the processor has 8 cores, each of which has 8 threads. So the operating system would see that as 64 different processors. Okay. There are ways of telling on a given T-series system exactly what physical resources are available. So when it comes to creating domains, it's quite straightforward to actually allocate resources between your different domain systems. So we're using something called a T5120 to do this demonstration. Okay. Of course, the system also has other resources such as memory, hard disk, PCI bus, which can be split between various domains, and of course network interfaces, as well as what other things you might like to add, like host bus adapters, for example, to connect to the SAN. This is what we're going to look at during this demonstration. Okay. First of all, a little bit of positioning, typical server uses, and a little bit of a look at the server firmware, which is a vital component of actually creating the domains and managing the system as a whole. The firmware being the piece of software that is installed in the factory and sits between the hardware and the operating system. The Open Boot PROM, for example, and the post power on self-test software. And you'll see how that works very shortly. Then we'll quickly move on and look at the interesting aspects, the practical demonstration of how you go about configuring a T-series server, installing Solaris, although it does come pre-installed, installing and obtaining the logical domain software, which is, as Dave mentioned, now known as Oracle VM Server for SPARC. The types of logical domain that can be created, creating something called the control domain, which, if you like, is the controlling operating system from which you create and maintain the other domains, which are typically known as guest domains. And it's within the guest domains that you create and run your applications. We've pitched this webinar assuming that most of you will have had some Solaris admin experience. So I'm going to mention things like, install Solaris, but without actually explaining too much about how to do it, and assume that you would have the skills, from the past to understand what I'm saying. Of course, there will be times when you can pitch in with some questions. Please do so at the appropriate times. As Dave mentioned also, SkillBuilders have been involved for quite some time now in installing, selling, installing, configuring, maintaining T-series servers with some fairly complex configurations, one of which I'll show you shortly to give you an idea of the level of complexity that you can reach. So it's a virtualization facility that allows you to divide hardware resources and run each system as a truly independent operating system. So it's not like zones or containers. It's not a software feature. It relies on the firmware to create the logical divisions, and you use the logical domain manager software to instruct the firmware basically as to how to divide up that hardware resource. It also has some fairly amazing facilities, like being able to dynamically change the resources. Okay? And in the latest version, you can dynamically change even the memory allocation of the system while the host is running. Not to mention assigning more CPUs if you think that's necessary, without having to do any reboots. Okay, so it's quite an amazing technology. So it sits somewhere between a software technology like Solaris containers or zones and something like the slightly older Sunfire dynamic domains that you may have come across in the past. Okay. Now, you can run Solaris on a logical domain, of course. That's the 1106 release onwards. And you can also run Linux and OpenBSD systems. And there's a couple of links there in the notes for downloads if you're interested. Obviously, the range of applications that you'd be running under Linux, being SPARC version, would be slightly less than you would normally expect on perhaps an Intel box. But nonetheless, you can run a Linux version. If you have any legacy Solaris 8 or 9 systems, you cannot run them directly in a logical domain because they do not support the Sun4V architecture. But you can create zones, i.e. containers, inside a logical domain, and then you can run your Solaris 8 and 9 legacy systems within that. And of course, with containers, you have resource controls, so you can assign a number of the CPUs of the system, an amount of memory, and so forth. So you can do some really good consolidations of an existing Solaris setup within your logical domains machine. And the machines have been referred to as a data center in a box. So take all your servers, put them into a T3 or T4, and then you've only got one physical system to worry about. Okay. Some of the uses are fairly obvious. Oracle recommend small to medium-sized applications and databases. But things like web, financials, name services, departmental databases are good candidates. Development and testing environments. Remember that because you have physically separate systems with physically separate operating systems, you can patch them to different levels, which is very difficult or nigh on impossible with a Solaris zone stroke container. And of course you have less physical hardware, so restricting physical access can often be much more simple with something like one of these servers. Okay. Now the system firmware is a highly important part of a system like this and is called an ILOM, Integrated Lights Out Manager. And that maintains the components that you would normally be familiar with on the SPARC system, like the power and self-test facilities and the Open Boot PROM. Okay. Basically what you do, you install Solaris on your T-Series server, and then you add the logical domains manager, and using commands within that, you then establish the actual domains that are divided into the firmware. Okay. There are certain issues about versions of the Oracle VM server software and its compatibility with the current version of the firmware. But when you download the software and you look at the associated README files, it will quite clearly explain the patch levels that you need and also the firmware revisions. Okay. Now you can access the firmware initially usually through a serial port, and I won't go into too many details about how to do that. I'm sure some of you will already be familiar with that. And of course, once you've accessed that, you can then set up a network connection, and usually access through something like SSH, okay, which is exactly what I've done here. And this machine has got the operating system installed on it already. There you can see the description. So I've installed my T5120 just like any other Solaris system. So there's no domains on there at the moment. The operating system version is, as you can see, update 9. I don't know if you're aware, but update 10 has just been released also. Okay. In this particular case, I haven't installed any patches or made any changes. It's just a straightforward install. The firmware side of things, it normally has DHCP enabled by default. So if you connect your system and switch it on while it's connected to your network, it may pick up an address, although it can be set statically. Okay. The login defaults are root, and the password is change me, just in case you ever get stuck. There's a handy bit of information for you. Here are some example firmware commands. So having logged into the firmware, which I can do because I've got, with SSH, because I've got the system set up. This would actually power on the machine, start/sys. Then I can start the console. And when I do that, I would then see the OK prompt that you would all be familiar with from let's call it a normal SPARC server. And once I've got that OK prompt, I can then proceed to build Solaris, either from a DVD or maybe a network build. And there's some more examples of setting network configuration within the firmware, which I can then commit to the firmware to make it permanent. Okay. I can also examine settings, and at the bottom there I'm actually committing the changes I've made so that they are permanently now within the firmware and will survive a reboot. Now, there's obviously many more firmware commands, and you can freely download or access the relevant manuals from Oracle. You don't need to access it through My Oracle support. Okay. And just to show you, here I'm actually connected to the T5120, giving its IP address, okay, and it gives me a login prompt, which is root and then the password. And in we go. Excellent. Just when you need it, it lets you down. Try once more. That's better. And there we go, a very fancy interface, but very, very useful, and it saves you having to know all the necessary firmware commands. Okay. I have one warning at the top there, and that's basically because I haven't changed the factory default password, but everything else is looking fine in terms of the management of the system. So a very sophisticated interface to look at all my server underlying faults, or if I want to know the temperature of a fan or whatever. A very nice interface. Even the ability to upgrade the firmware, assuming I have my Oracle support access to do so. And there's an example in the notes. Okay, let's have a look at the practical side of things now. Once I've got access to the firmware and I've started the console, I would get a normal OK prompt, as though I was on any normal SPARC machine, and I can then proceed to do an operating system install. I won't go into the procedures for doing so. I would assume most of you have had some sort of Solaris installation experience. But of course you can set up a network server to do your boots, which is exactly what I do, because I'm forever performing builds in a training environment. Okay? And so I would build Solaris in the normal way. The only thing I would say when you do this is that you have to make provision for disk space for your logical domains. And that's something we'll be looking at a little bit later. Now, having installed Solaris, you then need to obtain the Oracle software, the VM server for SPARC software. And you definitely need a support contract from Oracle to get access to do this. Okay? This particular file I've downloaded, it's purely for development and demo purposes, as is the operating system itself. And I've actually put this into a /root directory. Okay? And I would now need to unzip it. Okay? CD to the resulting OVM server directory. And there's the README file, which will contain all the information about the firmware compatibility required for this version, the supported hardware, the patch levels, and so on. Very clearly stated. So that's something important that you would normally want to look at. Again, to obtain patches and for firmware updates, you would need to go to My Oracle Support. If you're familiar with Sun Support, there's no longer the system handbook access, and you have to do it through your patches and updates access on My Oracle Support. And then search for your server under the Product or Family Advanced heading. And I've put a little slide in here. Sorry it's not very clear. But basically you have to search through the patch list to find your firmware update, and then you can download it and install it according to the instructions. Okay, so let's just stop for a minute, pause for breath. We've downloaded and unpacked the Logical Domains Manager software, which is here. We haven't yet installed it. Theoretically, we've checked the README file to make sure that we have the correct firmware version, and we've downloaded that firmware as a patch from Oracle. Okay. But that patch, by the way, for the firmware includes updates to the Open Boot ROM and the Post software. Okay. Now what we're going to do is actually install the software. Okay. This is a real installation. I haven't set up anything to emulate it. It's we're doing it for real on this machine, so you'll see precisely what goes on. In order to check the patches, you're probably already aware of this. You can use showred -p to make sure your patches are up to date, and then you can grab the listing to find out whether the recommended patches are there. Okay. But in the interest of time, I'm not going to show you how to install lots of patches. Okay, now we're going to just do an install, and while that's going on, we'll take a pause and maybe we'll take a question or two if you have anything you want to ask. So what I'll do, I'll just start the install running.
Yeah, hi Mick, this is Dave.
Hi Dave.
Couple of questions in the queue. What command shows available processors on the T-series servers?
That's thanks for that question. That's exactly the same as any other Solaris system, Dave. And the answer to that one is PSR-info. Usually -V to get a bit more information. Okay? And stand back in amazement when I press return. Okay. And here we can see the virtual processors starting at 0, operating at 1165 megahertz in this particular case. And the list just goes on and on and on and on. 0 to 63, making 64. So the answer to your question, Dave, is PSR info minus V.
Excellent. Another question in the queue, Mick. One of our administrators is just getting started to some extent, and where would a good place to find out how to install Solaris? Where would this person get started?
The best place, you know what I'm going to say, Dave, obviously, is come on a training course.
Mm-hmm.
It is something, I mean, there's many different types of machine. There's Intel processors, you know, there's this type of system. There are the non-Sun 4V, you know, like the M series, each of which can have Solaris installed on it, but in a number of different ways. And of course, you know, there's plenty of documentation on the Oracle website to help you. It can take a little bit of time to, you know, work out a particular procedure. So, you know, my answer would be come on a training course, and that is the best way. Yeah. You couldn't really distill it down into a short list, you know, that could apply to any particular server.
Okay, and I've just put in the link for the group, a link to one of SkillBuilders administration classes, so that might be helpful for one or more of the students. Yeah,
great. One thing I would say is once you've done a Solaris install, like any operating installation that you've ever done, it always follows the same pattern. You know, how do I partition my disks? What software options do I want? What's the date and time? What's the time zone? So all that is, you know, pretty standard on any install. But, you know, like now, when we do an install, we have to make other considerations like the amount of disk space. So let me get this software installed. So I've unzipped the software distribution, CD to the directory, and I'm running the install. It's asking me, do I want the configuration assistant, which provides a sort of supposedly user-friendly front end to configure logical domains. But I'm one of these guys, you know, like many sysadmins, who likes to see exactly what's going on. So I'm going to answer no and do it all myself. Okay. Now logical domains is installed. There's two packages that were installed. Okay. One of them being the LDM software, and another one that I'm not going to be using, that allows you to convert physical machine images into logical domain copies. Okay. So there's a little transcript of the install. There's a daemon running, a background process, which does all the work for you. So when you use the LDM command, it communicates with the daemon, which is quite a typical way of doing things on a Unix or Solaris box. And in this case, it's called LDMD. So we better make sure that it's running. And there we can see that it is enabled, it's online, it's looking good. We can also now use the LDM command, which was installed as part of that VM server for SPARC software. And the first thing I'll do is an LDM list, which shows what domains I've got. And it's showing my machine as the primary domain. This is the control domain. This is the machine that has control over everything we're going to do. And it has all the resources available to it. 16 gigs of RAM, 64 virtual CPUs, which we're going to change fairly rapidly. So we could actually run the machine just as a normal Solaris box with a heck of a lot of virtual CPUs and memory, but we're not going to. Okay, we're going to create some domains. First of all, we've got a control domain, which is the original Solaris system that we've just been looking at. We're also going to have something called a service domain, which has virtual services associated with it, like a network and disk. or a disk controller. We can also create an I/O domain, which is another input-output domain, but that actually has direct control over some of the hardware. So we can install a domain and then maybe portion part of a PCI bus or a complete PCI bus to that domain. And this is something we've done on a system to allow us to do I/O multipathing. So the system has two host bus adapters, and if one domain fails, the other one fails over, and all the domains carry on running. And it's also used where we've split the gigabit network interfaces between the domains. Okay. And then, having created those domains, you then create your guest domain. Okay. In practice, on a smaller, sort of less capable T-series server, your control domain will normally carry out all three functions. And indeed, the hardware might not have the capability of being split, so you can't really create a separate I/O domain for failover. But certainly something like a T3, it's eminently suitable to do that sort of thing. Okay, so we're just going to configure the control domain, and we're going to associate all the services with that, and then we're going to look at creating a guest domain. Okay. First thing we have to do is set up virtual services. We have to create a disk controller, we have to create a network controller, to which we can then assign devices that are going to be used within our virtual machines. Okay. Bearing in mind that we're doing a real installation here, we can go through these steps. So the system doesn't currently have any of these things set up. And to save me having to type it all in, I'm going to just select it, copy, and paste. This is creating a disk controller in the primary domain, and the add VDS is understood as meaning create a virtual disk service, which I'm calling primary-virtual disk service 0, because I can have more than one. Then I'm going to create what's called a virtual console controller, which will allow me from the control domain to telnet into my logical domains to display the OK prompt, for example, as though I'm on the system console. And I'm assigning the port range locally for telnet to see how to do this. And you'll see how this works a little bit later. Here I'm adding a virtual switch. There's some very powerful facilities within this software, and this is actually creating, to all intents and purposes, a network switch within the control domain. And once I've got that switch, I can then assign network ports to my my guest domains. In fact, I can have more than one switch through different I/O domains, and then I can use IPMP, Internet Protocol Multipathing, to provide failover across the different I/O domains, which is something else that we did on the T3 for the client. If I want to look at the services I've assigned at any time, I can do LDM list services. Whoops. Not quite as straightforward as on a Unix box. I have to copy and then paste. And there we go. So the reporting facilities of LDM are quite good. Now we have to configure the control domain and allocate resources. And there's three main types of resource. The processors, which we can think of in terms of cores or threads. The mathematical units, and there's one mathematical unit associated with each core, and an amount of memory. Now, because the control domain isn't going to be doing an awful lot, and it's not going to be running applications, I don't have to be too generous. So I'm going to provide it with one core, one associated mathematical unit, and 2 gigs of RAM. Okay. Currently, the system has everything. 16 gigs, 64 CPUs. Okay. So to allocate the resources, I need to find out what it's currently got, which I can do with LDM list bindings. Which is a slightly more verbose version of doing the LDM list. So I'd better pipe that through more. Here you can see all the core ID and the thread numbers. All the virtual CPUs and the memory. The virtual controllers that I've set up just now as well show up. Okay. It's a good idea if you're going to do quite a lot of configuration to do a list bindings and save it in a file. Just in case you're in a hurry, you need to try and remember what the original resources were that you started with. And I think that's a good idea all the way through, is to keep good records of the configuration, because it can get quite complex. Okay. I can list individual resources as an example. Okay. The MAUs are also known as crypto units, so LDM list -o crypto and the name of the domain. That's more relevant if we had guest domains. We can use the domain name to find out what resources are allocated against a particular logical domain. Okay. So right now we're going to allocate the resources. In a minute we'll be doing a reboot, and there'll be another opportunity to ask questions. Remember the process: copy, paste. We're going to set a number of CPUs. Usually done on a per core basis, certainly with guest domains, as the recommended way of making things the most efficient, but not too vital with things like a primary domain or indeed an I/O domain. What I'm doing here, sometimes the system is confused if I start messing around with the memory. So rather than try to do a dynamic reconfiguration of the control domain memory right now, which may complain, I'm going to get it to do the reconfiguration of it delayed until I do a reboot. Okay. And that's the start recon. Now I'll set the memory, but this won't take effect until I actually do the reboot. Okay. Now I've got everything set up. I need to do a reboot to make all those things come into effect. So I'm just going to do a straightforward reboot. Don't forget, if you've applied patches and whatever, you would normally do an init 6 to make sure they get applied. So I'm going to do a reboot, and then we can pause for a minute or two and take questions. Okay, and the server, of course, has now gone away until we access it again. Okay, so I'll close my putty and hand over to Dave to see if he's got any questions.
Thanks, Mick. Indeed we do. A couple of questions in the queue.
Yeah.
First one I believe I can handle. Is the presentation we're doing today going to be available afterwards? And yes, it will. We record these presentations and put a link up on the website for them, and we will send all the attendees the link to the recorded presentation, so you could view it anytime you want. Second question, Mick. you'll have to handle for me.
Sure.
What if you want to know the allocated resources for a specific LDOM?
Right. You would then, and I could show this a little bit in more detail later, but all you have to do is, if we go back a bit, you can do LDM list bindings space and then the domain name. So we could say LDM list bindings primary. Very shortly, once the machine reboots, we can have a look at creating a guest domain, and then, you know, as part of that process, I would give the guest domain a name, okay, like DB server or something, and then I could do LDM list bindings DB server. And that's the answer to the question, Dave.
Great. One more question, Mick. How the question is estimated duration. How long do you estimate it takes to set up and configure these guest domains?
The initial one has to be installed like any other Solaris system. So a couple of hours, you know, if you're going to plan it properly and install it. But you can install it in such a way, especially using the ZFS file system, where having installed it, you can do something called a sysonconfig, which takes away all the identity of it, okay, and then you halt it. And then you can actually snapshot the entire operating system and clone it. And you can, incredibly, roll out an entire operating system in a few minutes.
Brilliant.
Which is what we did with our client.
Pardon, Mick, I think I interrupted. Say that again?
Which is exactly the way we went about it with our client.
Very nice.
But of course, and if you want to, if the operating systems are, you know, wildly different in requirements terms, you can install each one individually, and therefore you'd be looking at a couple of hours in each case. Okay.
Thank you, Mick.
You can roll them out in minutes. Okay. My putty. Whale is the Dolphin is the firmware, by the way, and Whale is the logical domains control domain that we just rebooted. And thankfully, for our demo purposes, the machine has come back fine. Yeah. And there's our LDM list. If you remember, it had 64 CPUs and 16 gig of RAM. Now it's only got 8 vCPUs and 2 gigs of memory. So all the other resources are now available to us using LDM commands to configure guest domains. So that the control domain is now up and running. Yeah. There are issues about when you use an LDM command, it stores information within the firmware, but there's an intermediate phase where it's recorded within the operating system, which you have to be aware of and make sure that that information is correctly written away to the firmware. Okay. And there's various commands like to add a configuration to the firmware, so that would take whatever the current configuration is and write it away with a name called primary initial. The only one that's there by default is something called factory default. Okay. So if you're experimenting and you make a mess and you want to clear out what you've done, there's a couple of ways of doing it. You can do it from the operating system. You can set config factory default, or you can do it at the ILON, the lights out manager, by doing this command at the bottom of the page here. The one above would be on an older T1000 or T2000. Okay. I'm not going to bother doing anything like that because I'm purely demonstrating. Now, one thing we now need to do is make the virtual switch we created accessible to our physical network, okay, which it currently isn't. And then that way, any guest domains that have virtual network interfaces connected to that switch can then access the outside world. Okay? If you want a complete data center in a box without any access to the outside world, you can do it without doing the next step. Okay? So let's find out what network interfaces I have. Takes a little bit of time to come back. There's my virtual switch. So what I'm going to do is configure that as my main network interface. Okay. Or rather, I normally would, but in the interest of time, I'll just talk you through it. Currently, I've got an E1000G0 interface through which I'm communicating. Okay. And what I would do is replace that with exactly the same configuration, but for a VSW0 interface, okay. Which is shown. The procedure for doing this is shown on this page here, 32. Okay. So take down the E1000G0, unplumb it, which effectively, if you like, removes the driver from kernel. Plumb the VSW0 interface instead and bring it up, and then create the necessary file in etc hostname.vsw0 rather than hostname.e1000g0, and then the next time we reboot it will use that interface, okay? And then that way the switch now has access to the physical network. Okay. We can actually investigate properties of the network settings rather than list bindings, you know, and displaying everything. The LDM command has some pretty good ways of displaying specific information. It's just trying to remember what the commands are. But there's an example to look at the network. And when we set up networks within our guest domains, there'll be VNet 0, VNet 1, and so forth. And we can configure them like normal physical interfaces. One thing we have to do also is enable this VNTSD daemon, which will then give us access to the telnet ports, so we can access the OK prompts of any logical domains we create. Now, when we install guest domains, we will provide resources to the domains and also a disk to use. And the disk can be a physical hard drive, it can be a file created with Mick file, or it can be a ZFS dataset, which is what we're going to use. This system is using the ZFS disk, which you can there see. That's a DF listing, which, if you've never seen ZFS before, looks a little bit different to the normal. And just to show you, first of all, to find out what resources we have available, you can do an LDM list -devices, and that will show the actual hardware that's currently available to all the systems. Okay, so I've explained that you can use a number of different disk backends, and you can also extend a domain by associating others. You can, of course, use SAN devices, iSCSI, whatever you like, just like you can for any system. But we have a ZFS file system, and what we're going to do is do a ZFS list, and we have a pool called rpool. And what I'm going to do is create a little data set within it to store our logical domain volumes. Okay. And ZFS has this nice little facility of being able to clone systems. So if we create a volume within ZFS, we can then snapshot it and clone it and automatically be able to roll out another copy of the operating system. And if we sysunconfig it before we halt it, when the system boots, it will go through an identification process asking us the host name, the IP address, and so forth. So every time we want to create a domain, we simply clone the snapshot, assign it to the domain, and boot it. And then answer the questions, and we've got ourselves a brand new operating system that takes up very little space. So it's very economical at being very quick. It's not always the best way to do things, but certainly if you're going to roll out a lot of similar logical domains, it's a great way of doing it. Okay. So, it's often referred to as a golden image, as it's shown on this slide here. Okay. So let's have a look. First of all, we've got to create the holding area, if you like, the data set that's going to hold our actual volumes. The pool on this example is called pod, but mine is called rpool. Okay, so now I'm going to create an emulated volume. This is, by the way, sorry to bandy these terms around like emulated volume, but what I'm effectively doing here is creating a disk device sitting on ZFS that will look like where are we? And we'll just we'll call it gold vol, as though we're going to use it as an image, but we're actually just going to create a domain using that as though it's a disk, and that will create actually associated disk device names that we can now use and assign. Yeah? Like the example there at the bottom. So we can do LDM add VDS dev /dev /z vol, okay, /rpool /eldon vols /gold vol, and we're going to call that gold disk. And remember, primary -VDS0 is our disk controller. So we've attached a disk to our disk controller, and we're going to use that very shortly. So let's quickly go through adding a domain. And another 5 minutes and we should be pretty well there. Okay. I'm just going to use my copying and pasting again. I'm going to call the domain HPF1. It can be called anything, but I happen to live at a place whose initials are HPF. Here I'm adding the MAU unit, adding the CPUs. This is a repetitive process, and the only thing that varies between different domains is the actual resources you configure, which can dynamically be changed while you're running. So if you didn't quite get it right, don't panic. You can add or subtract any of these resources dynamically. Here I'm adding a virtual network to VNet 0, so that we'll have a VNet 0 that we can configure with ifconfig when the domain runs. And here we are assigning the disk. making sure the domain boots. Sorry, just come back. Remember to copy that. And set the default boot device, which is the disk that we've just assigned. And then, fingers crossed, we can bind the domain. Which then assigns all the resources, and it would have given us an error had I made any mistakes with all that typing. So that was the most tricky part of the presentation. Again, as I've shown you, you can do a list bindings to find out what those bindings actually are. I can do a list domain, and there's a list bindings, which shows you the number of resources that are actually allocated. Okay. Then I can write my configuration away, and then I can start the domain. I'll do it the other way around to the notes. If I do an LDM list, I can see the port to which I can telnet to get the console. And I say telnet localhost, don't forget this is on the control domain, to that particular and there we go. We've got our new logical domain, and there's the OK prompt, which which responds to all the normal SPARC open boot from commands that you're familiar with. Okay. Now we can do a bootnet. We might have to set up a boot support on a boot server. We can associate, by the way, the same way that we associated the actual disk device, we can associate a CD or an ISO image to build from as well. Okay.
Hey Mick, we've got a few questions in the queue, if I could throw them out to you.
Yeah, we're just about finished actually, Dave. I'll just put the last slide up.
Perfect. We'll hold them. Thank you.
Just to remind people about the SkillBuilders capability in this area. But thanks everybody for listening, and let's have some questions.
Thanks, Mick. A couple of questions straight away. Can you recap the difference between a logical domain and a container? Maybe benefit, disadvantage, or pros and cons?
The logical domain is a distinct hardware feature. So you're effectively creating a physical system, and you install and maintain the operating system within that separately. So your admin load would increase a little bit more with logical domains, but you could have completely different operating system installs, patched to completely different levels. With a container, that is a software facility. So if you had a Solaris box with containers, you would be running an initial version of the operating system called a global zone, and then you would create further zones or containers within that, but they'd be using the same kernel. So the virtualization is done through the kernel facilities and other daemons that maintain the separation between the different zones. And it's virtually impossible, for example, to have those machines running at different patch levels, certainly within the OS. But, you know, that's the free technology that comes with any Solaris box, and highly suitable for certain types of application. But when you want full separation with different hardware for extra stability, where no container can impact on the other, then a logical domain would be the obvious choice.
That's great. Another question, can I use SSH to access the LDOM?
You can, Dave, but not until the LDOM is actually installed with Solaris. You can't access the OK prompt like I'm doing using the SSH. You would only be able to do that with the firmware. So I'd have to look to get access to the OK prompt of the logical domain. I would have to log into the control domain first and then use telnet. But once the logical domain is built and you've configured SSH, maybe for root access, then you can log into it just like any other system. So that's the answer to that one, Dave.
Great. Mick, can you also recap the critical domains? For example, I/O domain. I believe there was also a control domain and guest domain. And what are the memory requirements associated with these domains?
They are service domains, if you like. The main domains are your guest domains. So if you took our client as an example with the T3, their guest domains are running Oracle databases, and therefore each domain is sized according to the requirements of the applications you're going to run. Okay? Just like you would size any other Solaris system. The control and the I/O domains are maintained separately, and although they can run applications, in the particular case of the client we know about, they are purely there to service the guest domains, and therefore they only need enough resource to run the operating system. So a single core is, absolutely fine, and a couple of gigs of RAM. Okay? But just like any other domain, if we find that allocation is not quite enough, we can dynamically change it while the machine is running. Okay. Now, if we go back through the notes, I can show you, going back to page 35, our current project, we've created a control and an I/O domain. So we created the logical domain, and we've given ownership of a PCI bus to it, so we can actually physically apportion the hardware to an I/O domain. So the control domain owns a PCI bus, and the I/O domain owns another PCI bus, each of which has an HBA controller connected to the SAN. And the guest domains are configured so that they will use one or the other pathway, and if one of those fails, it will switch over to the other domain. Having said that, not all T-series have the ability to split the PCI buses in that way. It just so happens that the T3 server that we're working on does. And that can also be done by splitting, you can split the network interfaces across both domains also. And you can therefore create multipathing such that if one domain fails, it will automatically use the other. And so it's surprising the level of resilience you can build in to a single physical machine. Okay. In our case here, the system is, the control domain acts as a single I/O domain and a service domain as well. The service domain has the virtual services associated with it rather than the physical ones.